Hello all and welcome to the lesson 4. It is on the remainder and factor theorems. The learning objectives are to evaluate functions by using synthetic substitution and to use the factor theorem to determine factors of polynomials. The keywords you'll come across are synthetic substitution and depressed polynomial. Synthetic substitution, we have already come across this, will be used to solve the remainder theorem. Depressed polynomial, we will come across this term in the factor theorem and I will explain you over there. So now let's go to the first example. We need to find the remainder using synthetic substitution. Now over here, this f of minus, they have given the f of minus 3. The function is given. So you can solve it directly by substituting instead of x as minus 3. Okay, the way is very simple. Now over here, instead of x, you need to substitute minus 3, the whole power 4. Everything else remains the same. Plus 3 into minus 3, the whole square, minus 15 into minus 3 plus 9. Now, if you do not have a calculator, taking it to the power 4 square, adding, subtracting would take a long time. Since you have calculator, it is very easy to find it. You can easily do that. But otherwise, synthetic substitution would be much better way. Now you can see over here, x is equal to minus 3, right? So what exactly happens is, here this comes inside. So the term would be x plus 3. So let's do the synthetic substitution. F of x divided by whatever is the remainder over here. Sorry, whatever is the term given over here, it'll be plus 3. Okay. Now, when we do synthetic substitution, we have to change the sign, isn't it? So in this remainder theorem, you can directly take the answer over here. So if you're doing synthetic substitution, you can directly take minus 3. And now the coefficients of these. Minus 2 is for x, 4, x to the power 4. There is nothing cubed, so it's 0. Then 3 minus 15 and 9. Next is starting the synthetic division. You need to bring this down, the first term. Bring it down as it is, multiply with this term, and over here you write it. That would be plus 6. Negative times negative is positive. Add them up and you will get 6. Now same thing is continued. Now write over here negative 18. Add them up, right? Multiply over here. Write it over here 45. Add it 30. And 30 times minus 3 is minus 90. The answer you get is negative 81. So synthetic substitution gives you the same answer if you had substituted this minus 3 over here. You can check by substituting this minus 3 over here. The answer would be the same. But if you didn't have a calculator, synthetic substitution would be much easier. Now, since you have the calculator, it's up to you. You can easily do any of the method which you're comfortable. The more easier method would be direct substitution and getting the answer. Now, going on to the next topic, the remainder theorem problem itself. Where is it used practically? Now let's apply the remainder theorem. Now there's a real world problem where the total production of eggs in billions in the United States can be modeled by the function f of x equals 0.007x to the power 3 minus 0.149x squared plus 1.534x plus 84.755. Now here this is important where x is the number of years since 2000. So now if they ask you and they have told predict the total production of eggs in 2025. Now this is very important. If they ask you 2025, you need to do 2025 minus 2000. Why? The x value will be 25 over here because any years after 2000 is only considered for this equation. It's not going to predict anything before 2000, since 2000. So here this is important. Now over here, since they ask you 2025, you need to subtract 2000 and you'll get the answer 25. Now here, this means x is basically what x value you're finding is 25. That is f of 25. So you can do it in synthetic division or you can do it in calculator. Remember, for synthetic division, the sign over here as it is, it'll be 25 itself. Now write the coefficients over here, all the coefficients, and you can do the synthetic division. Now over here it is, these numbers are difficult. You need a calculator. You need to multiply this with this. You'll get over here, add them up. So this is the answer, 139.355. Or if you just apply over here 25, sorry. Now if you apply 25, I would ask you all to do this. Try applying 25 over here. Instead of x, it'll be 0.007 25 the whole cube. Same way, put over here x, and wherever x is there, put 25, and then check the answer. It must be the same. We will do it now. All you need to do is 0.007 into 25 cube minus 0.149 x squared, that is 25 squared, plus 1.534 into 25, then lastly plus 84.755. So the answer over here is 139.355. Now there is one more important thing. The eggs are in terms of billions. So whatever the answer we get is in billions. So in the year, now if you substitute 25, whatever answer you get is the number of eggs that will be produced in year 2025. So if you're not understanding the synthetic division, you can always remember, just find the x value. What is the x from 2025 to 2000? It's 25. Substitute the x instead of in the given function. Over here will be x will be 25, and then solve. That would be the remainder. That would be the answer.